Hello, my name is John Moyer, and I want to welcome you to the NIH Office of Disease Prevention's Mind the Gap webinar series. This series explores research design, measurement, intervention, data analysis, and other methods of interest to prevention science. Our goal is to engage the prevention research community in thought-provoking discussions, to promote the use of the best available methods, and to support the development of better methods. Before we begin, I have some housekeeping items. You can submit questions during the webinar via the chat pod. You'll need to open the pod by clicking on the chat icon located in the lower right-hand corner of your WebEx window. Please direct your questions to all panelists. We will open the floor to questions that have been submitted via WebEx at the conclusion of today's talk. The slides and video recording will be posted on our website, prevention.nih.gov/mindthegap, in approximately 2 weeks. You will receive an email when they are available. Lastly, we would appreciate your feedback about today's webinar. Upon closing the WebEx meeting, you will be prompted to complete an evaluation. We would appreciate your feedback as it will help us improve this webinar series. Unfortunately, Dr. Murray is not able to attend today's webinar, so it's my pleasure to introduce today's speaker, Dr. Sean Grant. Dr. Grant is a research associate professor with the Hedco Institute for Evidence-Based Educational Practice at the College of Education, University of Oregon. His scholarship focuses on the generation and use of research evidence across the social, behavioral, and health sciences. As a methodologist, he is specifically interested in research synthesis methods, open science practices, and online Delphi processes due to their significant influence on the credibility and utility of prevention science for policy and practice decisions. His work on these methods also involves collaborative translational research focused on specific topics such as substance use and mental health. He currently provides service to the field as the methodological transparency editor of the Journal of Research on Educational Effectiveness, an associate editor of both Systematic Reviews and Trials, an associate methods editor for Campbell Systematic Reviews, and an editorial board member of Prevention Science. Welcome, Dr. Grant.
Thank you, John, so much for that kind introduction, and to ODP for having me today, and for all of you attending or listening to the recording, for giving your time for this topic that's near and dear to my heart and I love chatting about. So both today and going forward, please get in touch. Would love to talk to you about transparent, open, and reproducible prevention science. So I wanted to give you an outline of the webinar. What we're aiming to do is provide an overview of open science for prevention researchers. The topics that we'll cover in this 1-hour webinar include factors motivating interest in transparency and reproducibility, both in prevention science and I think in sciences writ large. What research practices are associated with open science or open science practices, and stakeholders who are engaged in and impacted by open science reform efforts. In addition, this webinar will discuss how and why different types of prevention research could incorporate open science practices, as well as ways that prevention science tools and methods could be leveraged to advance the wider open science movement. We'll identify activities that aim to strengthen the reliability and efficiency of prevention science, facilitate access to prevention science products and outputs, and promote collaborative and inclusive participation in research activities. So to start, let's look at the factors motivating interest in this. Focusing specifically on prevention science, our field, as many, if not all of you know, aims to understand important societal problems, identify effective interventions to address those problems, and then translate that scientific evidence into policy and practice that's evidence-informed. And the potential influence, therefore, of prevention science on significant societal problems and inequities and public resources to address them demands a high level of scientific rigor and research integrity. Consequently, prevention scientists have worked to establish methodological and ethical standards that yield valid and actionable evidence. And as it has done previously, our field continues to revisit these standards and norms in response to new opportunities and concerns, starting with constructive discussion and debate. And so to that end, we've seen this growing interest among prevention scientists in the last several years in the potential for transparency, openness, and reproducibility to facilitate this mission of prevention science. and to do so by providing opportunities to align scientific practice with scientific ideals, accelerate scientific discovery, and broaden access to scientific knowledge. I'd like to note that there is growing support for open science. Having worked in this area for over a decade, it's really exciting just to see at the beginning of this calendar year, the White House declaring it the year of open science, and numerous federal agencies, including the NIH, being a part of this year of open science. And for those who are new to the term, open science in general is about making the scientific process public and audible, and to ensure that the free availability and usability of scientific knowledge is the norm. Examples of open science practices that we'll discuss later include registering your studies, your protocols, and your analysis plans for your studies in advance, sharing your data, your analytic methods, your code, or other research materials publicly and freely, reporting and disclosing all of your methods and findings in your narratives, in your journal articles, and your study reports, and disseminating all of these research outputs via open access outlets that are free to access to the user. And as awareness and support of these practices has increased in recent years, conversations in most disciplines, including prevention science, have, I think, started to evolve from whether open science should be the norm or something we should move towards, and rather to how to implement these transparent, open, and reproducible research practices. And as fields transition to open science, there are some pragmatic concerns that researchers have raised about the potential for additional burdensome bureaucracy and regulation, stifled creativity and discovery, and inappropriate applications to studies that aren't based on the hypothetico-deductive method, so the experimental method where a lot of these practices come from. And so we hope to facilitate and continue that kind of conversation in our field of prevention science. In our field, some of you might be familiar with the Society for Prevention Research, or SPR. It's identified the relevance of specific open science practices in previous work over the last decade or so, such as Task Force on Standards of Evidence for Prevention Interventions, as well as ethical issues that have been encountered by prevention scientists. But to promote further discussion focused on open science, I and some colleagues led a special issue of the journal Prevention Science, the flagship journal of SPR, on transparency, openness, and reproducibility in the field. The issue begins with a primer that introduces and reviews key concepts similar to this webinar, and then there are subsequent papers that provide deeper analysis on the implications of specific concepts from open science to prevention science and prevention researchers. Flagging it because overall, I think it provides a great read on transparency, openness, and reproducibility for our field. And so if you haven't checked out the special issue and what we talk about today generates some interest, I really highly encourage you to go there. A lot of great materials and people in our field who would love to, I think, continue this conversation and collaborate on the topic. In terms of the rationale for open science in prevention science and sciences writ large, one of the reasons why people support transparency, openness, and reproducibility is that they see them as inherent in fundamental scientific ideals, such as communality, universalism, disinterestedness, and organized skepticism. So for example, being open in our work can better enable other researchers to verify our own work and for us to verify the work of others in mechanisms like peer review and journal submission. And this verifiability relates to the ideal of science as self-correcting, meaning that the scientific community governs itself in order to calibrate our evidentiary claims and limit unavoidable errors, thereby safeguarding credibility and instilling trust in the literature, which is very important for prevention science if we're really big on translating our evidence to inform important policy and practice decisions. And because this verifiability requires researchers to provide empirical support for their claims, practices like data sharing enable the verifiability of these empirical claims beyond what you can verify just from a narrative report in a journal article. And so we think that open science bolsters research integrity by facilitating this kind of verifiability. And as researchers increasingly espouse the ideals that are listed here, the norms on the left versus the counter norms that too often are actual scientific practice, we think that making open science the norm would actually better align actual scientific practice with the ideals to which scientists often subscribe themselves. Open science also can accelerate the progress of science as a cumulative enterprise. We often talk about science as something that's cumulative, that builds off its past. Proponents of open science see open science as a way to facilitate that aspect of the scientific enterprise. Transparency and reproducibility facilitate the reuse of and building on the work of others before us, which can lead to greater returns on research investments. For example, openness enables collaborations that are not possible through siloed research, such as crowdsourced initiatives that build large data sets to create opportunities for a greater number of rich data analyses across a more heterogeneous source of populations and settings. If you're not familiar, the Psychological Science Accelerator is a distributed international network of hundreds of psychological scientists all over the world, and I think it's a great example of this kind of open collaboration. In addition, data sharing also yields greater power to investigate newer, more complex questions. For us in prevention, that could be intervention effects on rare outcomes that you might need to have longer follow-up and bigger samples to detect, subgroup or moderated effects, or perhaps moderated mediation in different subgroups, and all of which require kind of large sample sizes that are typically found in just one study. And so sharing data from multiple studies can facilitate answering those kinds of questions that are key to our field. And adopting protocols, software, and analytic strategies from previous studies can increase standardization and training in our field, facilitating more efficient discoveries and even meta-analyses and research syntheses that summarize the cumulative evidence within a line of scientific inquiry. And I know I personally have benefited quite a lot, especially as a student, from code that others have shared in, for example, meta-analyses that they've run. And so it's that kind of adopting not just data and reanalyzing that can facilitate scientific discovery, but sharing our protocols and our software and our code and other materials. Then another motivation is that the open science movement focuses on making our research products and outputs more usable and more freely available to everyone, which broadens access to scientific knowledge and resources. Put differently, if knowledge is power, open science through open access is access to that kind of power, the power of knowledge. There are disparities in financial, human, and physical resources across research institutions. These might be able to be mitigated by the free availability and reuse of protocols, of data, of code, of software, of educational materials from previous work by other prevention scientists. And then open access articles can be read online or downloaded freely by stakeholders not affiliated with research institutions that have journal subscriptions, such as non-governmental organizations, policymakers, and engaged citizens. And I know some of us are at institutions now, at academic institutions, that are struggling with renewing their subscriptions to peer-reviewed journals. So moving towards this open access paradigm is also great for researchers. And through this focus on free availability of research findings and products, open science can accelerate the flow of scientific evidence to the public. Concerns relate to increasing the credibility of the evidence that we produce as researchers. And one of the issues that's really targeted by open science, kind of by definition, are the problems that are caused by a closed workflow, where the norm is us basically sharing a narrative summary in a journal article with word limits at the end of a study. And this is of potential concern because researchers make numerous decisions across all stages of research, sometimes known as the research life cycle. And these stages include things like formulating your question, designing your study, collecting and analyzing your data, and then choosing what to report and disseminate from what you've found. And without a transparent research life cycle, we as researchers have undisclosed flexibility in making these decisions, what are sometimes called researcher degrees of freedom, a similar concept to statistical degrees of freedom. And these degrees of freedom enable specific concerns that have motivated the open science movement, in particular those who are really interested in methodological transparency and reproducibility. So for example, a closed research lifecycle hinders the ability to reproduce previous research. It facilitates selective reporting of studies and results, sometimes known as publication bias and outcome reporting bias, and other detrimental research practices. It prevents detection of unintentional errors as well as intentional misconduct, and it exacerbates perverse incentives for career in scientists. And so we'll look at each of these in turn right now. So over the last decade, scientists and other stakeholders have contended that the behavioral, social, and health sciences are experiencing what some call a, quote, reproducibility crisis. And this term comes from numerous large-scale collaborative efforts in economics, psychology, social sciences, and medicine that have found low reproducibility rates. So essentially taking studies that are in influential journals or influential studies in their field, trying to replicate the methods as closely as possible in a new sample and seeing whether they can get the same signals with regards to things like statistical significance, direction of effect, size of effect. And each of these efforts tends to find very low rates of reproducing or replicating those metrics from the original study. And while this irreproducibility can occur for substantive reasons, right? So moderators or heterogeneity across participants or samples, scientific stakeholders are concerned that the number of key research findings that cannot be reproduced is higher than expected or desired, including those substantive reasons. And it's particularly the case in high-profile scientific journals that might get more attention in media and decision-making by folks like clearinghouses that curate the evidence of prevention science and translate it for policy and practice. And so viewing this ability to reproduce findings as one indicator of many for the veracity of a scientific claim, these results are commonly argued to be evidence that a greater proportion of published research findings are actually likely false than is previously believed. So in short, we have a higher rate of false positives in our literature than we might nominally assume. That's the concern. And so things aren't replicating because there was never a finding, there was never an effect to replicate to begin with, rather than substantive reasons like heterogeneity across contexts. And this high proportion of false research findings, it can hinder our scientific progress, it can delay translation of research into policy and practice applications, it can lead to a waste of resources dedicated to research, and potentially it can threaten even the reputation of and public trust in our science. And while there are various determinants of reporting findings that are false and irreproducible, there are what are called questionable or detrimental research practices that may be important contributors that are often a focus of many advocates of open science practices. And some researchers may intentionally engage in these practices with full knowledge of their negative consequences for the credibility of our evidence. But it's most likely that most researchers do these practices unknowingly or under the belief that these practices are acceptable and compatible with research integrity because they're the norm in the field. And so they're seeing this as doing what one was trained to do, what is typical in one's field, and not realizing that these research practices are actually detrimental to the credibility of our bodies of evidence in fields like prevention science. But regardless of one's intention for using these practices or understanding of their consequences, these practices nonetheless have that detrimental effect on research integrity by inflating the false positive error rate in the research literature, by inflating our effect estimates for our interventions, impacting other metrics of the quality or credibility of our bodies of evidence. And there is evidence from meta-research, so folks who are doing research on the research process, that suggests that many of these practices are fairly common, if not potentially increasing over time in certain fields due to pressures to publish and get funding or other factors. I think chief among these detrimental research practices that gets a lot of attention is the selective reporting of studies and results, or really more accurately, selectively not reporting certain studies and results, which occurs primarily when the nature of study findings, rather than the methodological rigor of the study, influences authors' decisions to submit it to a journal, to disseminate them, or for those who are in curation positions like editors and peer reviewers to agree to publish them or think that they are publishable or worth publishing. And there is ample and longstanding evidence across many disciplines represented in prevention science and other areas of the NIH that statistically significant or positive results, all else being equal, are more likely to be published than results that are not statistically significant, that are null results, that are inconclusive, or maybe otherwise countervailing to the expectation in that area, or what might be seen as a paper that folks want to read. So again, kind of picking what gets published or what gets submitted for publication based on the nature of the findings as opposed to the importance of the question and the rigor of the study. Researchers may selectively refrain from writing up and submitting specific findings, or they could do so for entire studies for publication based on the nature or direction of results, leading to a biased subsample of studies that are in the public domain. And this is what can lead to inflated false positive error rates and inflated effect sizes in our published literature from this publication and reporting bias. It's been documented in psychology and education, core fields of prevention science, using evidence from protocols submitted to institutional review boards and full doctoral dissertations that shows what was actually collected and even analyzed for a given study, and then what was actually reported in journal articles, both the outcomes and then the nature of the analyses that are reported. And those have shown that studies with statistically non-significant results are less likely to be published. In clinical psychology and medicine, other fields aligned with prevention science, interventional trials with statistically non-significant results are less likely to be published than clinical trials with statistically significant results. And then in terms of NIH funding, there was an evaluation of trials funded by the National Institute of Mental Health that found that studies with small effects were less likely to be published than studies with large effects, potentially inflating the apparent effectiveness of psychotherapies in the published literature. So scientific claims based on these bodies of evidence, like calling a prevention intervention evidence-based and worthy of funding in our policy and practice systems, those claims are undermined as a result of this use of statistical significance, of the magnitude of effect sizes, of the direction of effects to make decisions about publication, as opposed to we posed an important question, we answered it appropriately and rigorously. So whatever we found should make its way into the scientific literature. Undisclosed flexibility from closed science is related to numerous other detrimental research practices that can virtually guarantee spuriously finding statistically significant or interesting results. So some other examples that you may have heard of in conversation on discourse in the open science movement over the last several years are things like p-hacking, which is referring to repeatedly searching a data set or trying multiple alternative analyses until a statistically significant or other desired finding is obtained, and then failing to fully report how this result was obtained. So failing to report all the different analyses that you've ran and then controlling for that through some factor for controlling for family-wise error rates. Another one you may have heard of is harking, or hypothesizing after results are known. And this involves reporting a hypothesis that was formed after seeing study results as if it were an a priori hypothesis that you formed before collecting or analyzing data. So in other words, you found a statistically significant effect in something like a correlation matrix, you think that's an interesting association, and then you try to think through or hypothesize why you're seeing that relationship theoretically, and then you report that theorizing in an article, but don't specify that this was something that you came up with after you ran your analysis. And so it gives more weight to that theory inferentially than maybe is deserved. This undisclosed flexibility can also hinder the ability of peer reviewers and readers to detect research practices that result in things like overfitted statistical models. So overly optimistic findings from a statistical model of a data set that do not occur in the target population due to idiosyncrasies of the sample at hand in that data set that you overfitted your statistical model to. And these spurious findings from overfitted statistical models, so things like linear regressions, logistic regressions, structural equation models, and other models that are common in prevention science, these spurious findings from overfitted models are highly likely to fail to replicate in future samples. And so this, again, threatens the credibility of any scientific claims we make that are supported by these findings from overfitted models. And so these are some of the other concerns motivating interest in methodological transparency and reproducibility. So what we want to focus on in this next section of the webinar are what I might call the core open science practices that are often advocated by folks active in this movement and seen in really influential frameworks, so that if at this point you're saying, okay, I buy into the importance of trying to make my work more open, how do I do that? What are the kinds of practices? This offers a roadmap or a menu of practices that you can try in your workflows and try and adopt over time. It's important to note that this set of core practices has largely arisen from idealized versions of studies that use the hypothetico-deductive method. So in other words, folks who do randomized trials and field and laboratory experiments that test confirmatory analyses, often using null hypothesis significance testing, so p-values in a frequentist statistical framework. And while the principles of transparency and openness, I would argue, are relevant to all empirical research in prevention science, it may be premature or undesirable to require specific open science practices for every type of empirical study a prevention scientist might conduct. So a goal of this webinar is to provide you, particularly those of you new to transparency and reproducibility, with an overview of these prominent practices so you know what they are and where they come from, and using that as a foundation for further discussion about various elements of open science and these practices that can and maybe should be applied to specific types of prevention science. So going through this roadmap for the next section of the presentation, starting with the practices that you would do before you start collecting data. And the first is study registration. So that is a time-stamped entry of a minimum set of information in a publicly accessible, independently controlled registry, like clinicaltrials.gov. So those of you who are doing NIH-funded clinical trials, you'd be familiar with this requirement to register your trial in clinicaltrials.gov. And researchers, while it's more common in using this in studies before collecting new data, theoretically, you can also do this before you are accessing existing databases. So let's think about what does registration look like for secondary analyses of data, or things that collect new data but are different from randomized trials. What is the motivation for this practice? Well, primarily study registration can address publication bias by documenting that particular studies exist, and then they can also serve as identification numbers that link the various products and outputs of a study. So if we move towards a paradigm, where we're not just sharing reports, but our protocols, our data, our code, our research materials, a registration number almost serves like an identification number, like a social security number for a study that can link all of these various products to a study. And in this way, a study registration can act as a one-stop shop for other researchers and interested stakeholders to discover and gather information on planned, current, and completed research on a topic, even if that research is unpublished. So if you're working in a given area of prevention science, let's say school-based depression prevention, searching registries like clinicaltrials.gov can give you a sense of not only what research has been completed in this area in terms of interventional trials, but also planned and current trials in that space. Related to registration, but somewhat distinct concepts, are prospectively sharing protocols and analysis plans as part of your registration. And a protocol is a document that provides details on study background, rationale, objectives, the design of a study, and your specific methods for data collection. And then the analysis plan provides even more technical and detailed elaboration of your procedures for executing any data analyses that you described in your protocol. And some of you might be familiar, especially if you do trials and register them, with the relatively recent clinical trials protocol template for the behavioral and social sciences, if you are doing an NIH-funded clinical trial. And so researchers can register these documents with their study registry, but there are also journals like Trials, where I'm an associate editor, that publish or share protocols and analysis plans in advance of data collection in order to pre-specify your rationale, your proposed methods, your analysis plan, and your management of a research study. And these are not meant to prevent exploratory analyses, but rather prospective registration limits the opportunity for detrimental research practices like switching the outcomes that you're interested in, selectively reporting analyses, outcomes, or studies, or harking, hypothesizing after the results are known, because it facilitates the ability for folks outside the study team to distinguish what was planned or confirmatory versus what was actual and exploratory study procedures after you started collecting data. So it's just to provide accurate descriptors as to whether analysis is confirmatory or exploratory. And they also encourage, as a benefit to you, I've experienced this, they encourage research teams to more carefully plan in advance. When one writes out their full plan in advance, it really helps sharpen one's thinking. There's sometimes what's clear in our heads isn't as clear when we try put pen to paper. And I found writing these things out to help clarify my thinking, to help me communicate my thoughts to my team, And then also you've got a good chunk of a draft of a results paper written out because you've essentially written the introduction and the method section for your final paper. So I think there are also some efficiency gains and quality gains of managing your project, in addition to the gains to the credibility of the evidence that you produce. And so that ties into kind of the next column in our roadmap, which is organizing your workflows and managing your projects once they're ongoing, once you start data collection. And this involves folders, files, metadata, managing your code, other data documentation as part of your workflow. And the goal here is to organize your workflows coherently and to document your file management procedures clearly. And particularly through areas like computer science, there are actually guidance and standards that we could potentially, plug and play into prevention science. So there's a wheel here that we don't need to reinvent. And these guidance documents tend to recommend that a organized, reproducible workflow includes things like clear computing and communication, version control that tracks changes in real time across collaborators and versions of things like your lab notes or your code, or if you're writing the report together. And ideally, you're doing this with some sort of cloud-based service. So sharing this in something like OneDrive and Microsoft Teams that tracks these things over time, that you're tracking the chronology and origin of research objects, so where are your data and source code coming from and how have they evolved over time, and ideally using some sort of computational environment to share with others who would like to repeat your workflow. So things like CodeOcean is one example. And ideally, researchers maintain a dynamic digital notebook that records decisions that you've made throughout the research lifecycle. And then you make this notebook publicly available after study completion. Not being the most tech savvy person myself, I've just started this out by having a Word or Google Doc that's shared with my whole team, where after every team meeting, we log decisions that we've made about our study design so that when we're writing the final report, we can track why we've made certain decisions and then be explicit and transparent in our final reports about what might have changed from when we published the protocol before we started data collection and analysis and with the final results paper you're seeing. Then when you get to the stage of writing up your results, we're thinking about things like transparent reporting. And if you're already at this point in this presentation wondering, there are so many practices, open science practices here. Some of them seem quite technical. I don't know where to begin. I'm a bit intimidated. I think that this is a great place to start if you're completely new to this and are looking for one practice to take on board for your next project. And this is trying to get at the problem caused by incomplete reporting, which leads to the omission of information that's essential for others to appraise the quality of your study, to reproduce your findings, and then if your study is eligible for a systematic review, to synthesize your study as part of the body of evidence in your area. And so the Equator Network shown here, and the link for the website's in the bottom, is essentially a library of reporting guidelines for various study types. And reporting guidelines use explicit methods to create a list of reporting standards or a checklist on the minimum set of information that you should include in a manuscript for a given study, like randomized trials, observational studies, systematic reviews. And if you include the things in the checklist, you should be providing an accurate, complete, and transparent account of what you did and what you found in a study. The checklist tends to be organized around the different sections of a manuscript. So the IMRAD format, intro, methods, results, and discussion. And then they often contain flow diagrams that capture the flow of, in the example of a randomized trial, participants through the trial, from the number you've approached to the number you've recruited, the number you've randomized to different study groups, and then how many people you retain at different outcome follow-ups. And this Equator International Initiative provides a catalog of reporting guidelines, and they keep it up to date. So it's something that I highly encourage you to visit when you're designing a study, because it's helpful at the protocol stage. Some of these checklists are even for the protocol stage. But it helps you know the goalposts, as many journals are adopting these guidelines as part of their peer review. And then when you get to writing up your final results paper, it's helped me write them a bit faster because it helps that static friction of, where do I start when I start writing? Gets over that initial writer's block because, oh, I need to report these details about the methods and these details about the results. So I think this is a great place to start. It's where I got started in the open science movement. But then in addition to sharing the narratives and having a transparent and comprehensive narrative, we want to think about sharing our other products. So these are things like analytical data sets with the relevant metadata or information about the data set, the code you use to analyze that data, and any related research materials like the materials you use to collect that data, all of which facilitate reproducibility. This is an increasingly prominent part of NIH-funded studies, and so I wanted to share the link here for the NIH site on sharing data and related materials. And so to safeguard the quality of these materials, you can carefully plan and describe management procedures at the beginning of your study for how you're going to manage and share your data. Make those procedures accessible to your research team during your studies, and then communicate these procedures to external stakeholders after your study when you share, when you deposit, when you archive your data, code, and other materials. And data relevant for sharing, depending on the study and depending on things like ethical concerns, legal or proprietary concerns, these can range from initial raw data to the final process data state, given the many judgments and choices that are made by study teams along the path of cleaning, transforming, and preparing your data for analysis. There are availability standards out there, if you're new to this, that offer guidelines for how to manage data, code, and research materials, and how to make them findable, accessible, interoperable, and reusable, the FAIR principles of data sharing. I personally like the ICPSR guidance, the Interuniversity Consortium for Political and Social Research, and they also, places like ICPSR that provide these guidelines, also provide a place for you to archive and share your data. But if you go to this website at NIH, you'll find different places, different tools, different papers out there on how to practice this open science practice. So thinking about these core open science practices, now we want to think about what are typical workflows in prevention science and how might one apply these to the different types of prevention science. So one core aspect of prevention science is investigating the distribution and causes of physical, mental, and social health problems among populations, epidemiological research. And this may be at greater risk of things that I mentioned earlier, like multiple hypothesis testing and selective non-reporting of results in studies because of increased capacity to fit increasingly complex models and potentially lose track of all of the analyses that you've run and not reporting all of them. And this non-reporting can waste resources, and it can increase the chances that the wrong risk and protective factors are identified and pursued in future intervention research. So project management systems like the Open Science Framework can offer prevention scientists conducting epidemiological research with free, open, and online platforms to collaboratively organize your workflows, to manage your files, to share your notebooks, and then reporting guidelines like STROBE, the Strengthening the Reporting of Observational Studies and Epidemiology. The STROBE statement is a reporting checklist that can help lead to more transparently disseminated observational studies, of which most epidemiological research consists of. Then thinking about that next intervention research stage, the development and testing of interventions, it's fundamental to prevention sciences. We take that epidemiological research, we pick important problems, we think we identify risk and protective factors that are malleable, and then we design and evaluate interventions to address those risk factors to solve those issues. And so from an open science perspective, thinking again about NIH regulations for clinical trials, study registration and transparent reporting are essential practices for this stage of research as well. You can have trial registration in clinicaltrials.gov to record important information about your trial design, particularly complete and transparent definitions of all of your planned outcome measures. And then all studies that prospectively assign human participants to one or more interventions, we think should be registered regardless of phase, setting, intervention, and outcome. If you're testing an intervention, if you're assigning human participants to interventions, trial registration is something that you should consider and do. And then recommended in Standard 8 specifically of the SPR standards of evidence for efficacy, prevention scientists can consult reporting guidelines when writing your manuscripts to ensure an accurate representation of their intervention evaluations. I was part of a group that extended the consort statement, which is an influential reporting guideline for randomized trials, to social and psychological interventions. And this identifies the minimum information needed to understand and apply the results of randomized trials that evaluate interventions thought to work through social and psychological mechanisms of action. So the kinds of interventions that prevention scientists tend to evaluate in prevention science trials. And to facilitate adherence to this checklist, there's also a user's manual known as the explanation and elaboration document that provides guidance tailored to the concepts, theories, and taxonomies that we use in prevention science. Translational research is the intersection between prevention science and public policy, in which insights from epidemiological and intervention research inform real-world policies and practices that promote individual and collective well-being. So public policy research includes not only researchers within academic institutions, but also individuals who are located within government agencies, within nonprofits, and other settings where research is often inaccessible due to internal paywalls. So open information systems are critical in building and using knowledge management systems to advance dissemination and implementation science. We think preprints and open access journal articles allow consumers of evidence and practitioners to have more direct access to findings, and particularly in the case of preprints, to make evidence more timely for decision making. CBPR, or community-based participatory research, entails unique challenges and opportunities for transparency and openness, given shared power structures with non-scientists, use of a broad range of methods, concerns about privacy, and often the use of unstructured data. But we argue that the forward planning and transparency demands of the open science movement may initially seem, while they may initially seem like an anathema to prevention scientists working in the context of partnerships with communities, they can actually improve the capacity for ongoing communication, transparency, accountability, and reciprocity in relationships with community stakeholders across all phases of prevention science. So rather than constraining action, we argue in the paper that is sort of the keystone paper of the special issue, that open science approaches may offer a structure for establishing agreements about key expectations, about workflow with community members, about how data will or won't be shared and who owns the data, disseminating findings in a way where others can reproduce those findings by having access to the raw data, and for reviewing and revising these agreements as the research progresses. So for example, collaborative partnerships between researchers and community members can include equitable access to and use of data sets. They can involve the return of results back to your communities, which unfortunately has not historically been the norm in our research. So we think this is a great example of where not focusing so much on the practices, but the principles of transparency and openness to a key kind of prevention research can lead to an improvement in the quality of the work that we do and the evidence that we provide. And then given the amount of attention to experimental and quantitative approaches, open science practices prevent unique issues for qualitative and mixed methods research. But there are qualitative scholars who are exploring how open science practices from experimental frameworks can be translated to qualitative inquiry, and its commitments to principles like validity, transparency, ethics, reflexivity, and collaboration, as opposed to things like reproducibility. So as an example, registration in this context isn't being used to establish experimental predictions, but to define the aims of a project, to outline your presuppositions before you go into the project, and then as something that you can update as your data are collected and analyzed, to track the development of your interpretive framework, and then potentially combat dissemination biases in the qualitative literature because you've kept good track of all of your thoughts and findings throughout your study. And then lastly, administrative data, because of the decreasing costs of obtaining big data sets, combined with our improved technology, is easier to conduct over time. And while these advances allow for high-powered analyses, they also risk spurious findings if multiple results are analyzed and calculated but reported incompletely. So we argue, again, in this core paper of the special issue, that prevention scientists using administrative data would gain efficiency and accuracy in the research processes by leveraging principles of data and computational science. So these would be things like organized workflows with consistent and predictable structures, having a standard folder structure for storing your data, your code, your outputs, and narrative reports using version control. And this particularly can lead to efficient updates to your report if you're using administrative data that has the same structure year over year. And when a new year or wave of data comes in, it makes it easier to do the analyses for the next year. So what are some challenges to this movement towards prevention science that came up through this development of the special issue? One is that prevention science commonly involves sensitive personal information from vulnerable populations. So we really do need to care. It can't just be lip service, but really think through sharing de-identified data, code, and materials in a way that doesn't increase risk to participants through violations of privacy and confidentiality. Researchers, particularly early career researchers, have also expressed concern about work being scooped or receiving excessive criticism from others, and tensions with intellectual property restrictions in the context of research that they do, like getting a special agreement to use school district data for their prevention research. So conversations need to continue in our field about things like appropriate embargo periods, where researchers have protected time to be the first to analyze their data and publish their findings, and then appropriate rewards to folks for sharing and citing data, code, and materials after this embargo period. Open science reforms also need to avoid reinforcing existing inequitable power structures by ensuring stakeholders from under-resourced settings, historically underrepresented and excluded groups, and diverse epistemic backgrounds are included in the influential reform discussions rather than those who already are in power reinventing or reinforcing the status quo in this reform effort rather than achieving principles like equity and inclusion that are also core to open science. There are potentials for open science to add to burdensome bureaucracy and regulation. So all of these checklists and things that we need to fill out, how is that going to be funded? What are the mechanisms for having folks in our field who have specialization in things like data science and data curation? Those are really important pragmatic concerns. And then lastly, we need to attend to the potential for open science practices to falsely signal quality. So just because someone says that they shared their data or registered their study, what is the quality of the registration they created of the data that they've shared? And let's not make those false signals for quality in our field. And so to end this webinar, I wanted to quickly talk about the various stakeholders in the scientific ecosystem beyond researchers who we might want to target with some of these open science reforms, because we exist in a context, and the researcher behaviors we've discussed today exist in a context, and if we don't attend to these different stakeholders that make up our scientific ecosystem, the chances of open science becoming the norm in a way that we'd like to see are much lower. So the first are journals and publishers, right? Publishing our work through journals is still the primary output through which we disseminate our work and get credit for academic careers and for research careers. So let's have conversations about journals in our field adopting things like the top guidelines, which comprise 8 modular standards that journals can incorporate into policies for manuscript submission and publication. Things like asking folks to disclose whether or not the data are publicly available, or requiring folks to share their data for particular types of research. Journals can explore with things like a registered reports format, where you submit the protocol to your study prior to conducting the research. And if that passes peer review, your study gets in principle acceptance at that journal, assuming that you stick to the protocol that was approved and or deviations to the protocol are justifiable from the perspective of the journal. And then continuing to explore with open access publishing mechanisms, and particularly ones that don't have high article processing charges. So it's not only free for the reader, but it is feasible for the researcher to publish open access in influential journals, and is not something that is already stretched budgets by universities and other research institutions. We want to think about funders as well, knowing that what gets funded influences what gets published, who has a research career, and the degree to which that research can be open. So for those of you interested in funders, the Open Funders Research Group, I think, is really at the vanguard of thinking through the role of funders to facilitate both transparent work that they fund, like registration requirements for clinical trials, as well as funding research on open science itself to see how we can make it the norm. Universities and research institutions also influence our behaviors as researchers, and given their role in potentially enabling these perverse publish or perish and funding or famine incentives to academic careers and academic positions, open science proponents are increasingly calling on universities and other research institutions to empower researchers to stop using detrimental research practices and to normalize rewarding transparent and reproducible research practices for career advancement in things like hiring, promotion, and tenure. And the National Academies of Sciences recently released a toolkit on things universities can do and ways to incentivize open science at US-based universities. And the Helios initiative is a great offshoot of that. So anyone who's interested in your institution being part of this movement, I recommend the Helios initiative. The website's there for you. And then I think particularly unique to prevention science, my colleague Evan Mayo Wilson at UNC and I have worked quite a bit with folks like Pamela Buckley, who runs the Blueprints for Healthy Youth Development Clearinghouse, to think through the role of open science for policy and practice decisions, and in particular, whether open science practices can be incorporated somehow into the procedures and standards that influential clearinghouses use to designate interventions as evidence-based, as these could influence researchers to use these practices in program evaluations, leading to an even more reliable evidence base for decision making. So if you're keen on that topic of the overlap of open science and evidence-based practice, we'd love to talk to you about that. And if you're keen on citizen science and public engagement with prevention science, there are a lot of great initiatives like Sense About Science and the Prevention Center at the University of Sydney who are thinking through open science as a way to opening the scientific process to laypersons who are really keen to be involved in the design and conduct and analysis and dissemination of the work that we conduct. I'll conclude with a call that I think open science reforms require broad communal effort. They require social and behavioral change. And so I think we as prevention scientists are actually in this very unique position to advance the open science movement. We have expertise in identifying problems and identifying the causes of those problems that you could change with an intervention, designing interventions to make those changes, evaluating them rigorously, and then translating evidence-based interventions into policy and practice. And so I'd love to think more with folks about ways that we can use the methods and theories and frameworks and tools from prevention science to advance the open science movement to make our research more transparent, open, and reproducible and inclusive. And so one way to do that could be leveraging program planning models where we create logic models of the problem to think through determinants, the potential mechanisms, and then the problems we're targeting, and match that with a program theory whose logic addresses those determinants through specific actions or interventions to lead to our desired outcomes of actions. So in short, I would love to foster prevention science as an open science community. And if anyone is really keen to continue this conversation, we have a special interest group on open science in the Society for Prevention Research. A lot of folks who are involved in the special issue are really keen on this topic. So please get in touch. Happy to answer questions now and then to keep the conversation going in the future. So thank you so much for your time today. And I really look forward to hearing what questions you have about this overview of open science for prevention scientists.
Great. Thank you, Dr. Grant. Yeah, we have a few questions.
Great.
One question was how open science and like intellectual property concerns like patents intersect. Do you have any thoughts or comments on that?
Yeah, it's a great question. And so I think my initial reaction, happy to talk more later, is I would love for us to flip our mindset to have open be the default as opposed to closed, right? So we start a project thinking, how open can we make this? But understanding it might need to be closed to a certain bit, certain aspects of the project, and closing it only as much as necessary. And while ethical concerns are one area that get a lot of attention, I think intellectual property is another, and we want to respect the relationships that we form with groups like being in a college of education. I know school districts and companies who also help deliver curriculum and develop curriculum are key partners in the prevention work that we do. And maintaining relationships is really important, both ethically and for the quality of the work that we do. And so working with our stakeholders and getting to know folks at your research institution, universities, I think a lot of them have folks in offices administratively who specialize in IP, thinking collaboratively about that from the outset increases the chances that you can be as open as possible while being as closed as necessary for those kinds of restraints.
Great, thank you.
Thank you.
Another question that we had come in. So you presented some results of all these of many studies that were the reproducibility crisis slide. We're just not able to replicate existing studies. So this question kind of, or this comment from one of the audience members is saying we might also expect to see that kind of impact like in studies to assess these studies, like
Right.
meta-analysis to study. So
Meta research.
exactly. So what is I guess do you have any concerns that these studies that kind of are set out to show irreproducibility kind of are suffer from similar biases that um, plague the studies that they're studying?
Yeah, I think it's a great question, and I certainly think that the there shouldn't be blind trust in meta research, right? It is research, and applying our skills of critical appraisal and critical thinking to these studies is essential. I have concerns about anybody who says don't be critical about these studies, so I really appreciate the concerns. I think there are hypotheses there. There's some work that's followed up on some of these original studies to investigate whether certain biases, like how does one sample studies to replicate, right? Are you particularly choosing things that you don't think will replicate because you think not replicating a finding will be a more attractive narrative? And so you're kind of chasing those results to get publication in the same way that you're criticizing, traditional research is doing. So I think critical thinking about this is absolutely essential. I'm not concerned to the point where I don't believe that these studies provide empirical evidence to the kinds of issues that I've discussed today. But I certainly don't think any study is perfect, and would love to, dissect further and maybe even think of our own meta research to conduct to see which of these meta research studies to go for. But hopefully it's not turtles all the way down. Hopefully there's some firm ground that we land on and say, okay, fair enough. We think this is good enough evidence to act as if this is an issue that we need to correct in our workflows.
Yes, great. Um, Another question. Are there empirically based, systematic, or recommended methods for sharing research study findings to sampled community groups? So it seems like the question is focusing on kind of sharing the results
Yeah.
with the participants.
Yeah, it's a fantastic question, and I think a really important component that needs to be brought more into folks who identify with this movement. I can't think of formal titles of anything off the top of my head, but I do know that folks who work in human research protection programs, so IRBs typically are in human research protection programs or human research protection offices at universities. Folks who work in that space go to conferences like PRIMR, PRIMR. This concept of return of research results to participants in order to meet the ethical obligations of the principles of the Belmont report, like beneficence and justice and respect for persons, and how to enact that is a really big topic there. So either going to those resources online or perhaps contacting a representative of the HRPP or IRB at your institution about guidance they have or studies or colleagues at your institution that they're aware of who do this regularly, I think would be a great place to start.
Okay, great, thanks. And yeah, and one of the other audience members mentioned that clinicaltrials.gov also can publish results. So that's another.
Yes. Yes, that's a great place to publish results from things like your clinical trials. But I love the call not just to put them somewhere and expect it to be like the field of dreams. You built it, so you expect community members to go to our technical websites, but to really proactively go back to your communities and provide the results and sit and discuss with them what those results are. I really love the call for that.
Great. And I think we have time for one more question. The question's so where do you see the idea of technical performance studies, which are adapted from computational approaches, fitting into prevention science? Any thoughts on that?
I'm not sure if I know what is meant by
Yeah,
a technical
perhaps.
performance study, so happy to address that in the Q&A that we write up after this if the person wants to submit
Right.
more details on that. But I apologize, I'm not sure what that means, so I don't want to misspeak, but hopefully there's time for one
No,
more.
that's great. Yeah, yeah. If the question asker could maybe clarify, we can. Dr. Grant has graciously offered to answer the question after the webinar. So, all right, I think that's what we have time for today. So, thank you very much, Dr. Grant. And thank you to everyone who participated in today's webinar. On the Mind the Gap website, prevention.nih.gov/mindthegap, you will find several resources for this talk, including the slides and a list of references. We will also be posting a recording of today's webinar on our website in a few weeks. You will receive an email with a link to the recording when it's available. Thank you and have a great rest of your day.
Thank you.